Hey folks, Michael St. John here. Welcome to another session with the Validate Patterns SIG for OpenShift Commons. We have Johnny Rickard here today with us. He's going to be talking to us a little bit about HyperShift or the hosted control planes in OpenShift and Hives, and as it relates to how to work with those in validated patterns. So without further ado, I'll turn it over to you, Johnny.
All right, awesome. Thank you, Michael. Yep. So I'm Johnny Rickard. If you don't know, I'm not the foregone expert on HyperShift or Hive or anything like that, but I have been using HyperShift for the better part of basically 2024. I think. I mean, maybe a little bit late last year, but anyways, I have a presentation that Anthony shared with me this morning that I kind of trimmed up. That we're just going to go over a couple slides, just to kind of go over like what hosted control planes are. We'll talk a little bit about Hive. We're not going to deep dive into Hive too much just because of the amount of time that it takes to do things. But we'll go through this presentation. I'll run through the validated pattern that we created for HyperShift, and then we'll create a couple clusters and we'll scale some up and kind of see how it goes from there. So HyperShift is really about bigger, stronger, faster. So it's really about deploying clusters faster, saving as much financially as you can, and really getting that application user, the developer, or your customers access to whatever you're deploying faster. So if we look at the slide here, we have the start, which is like we're gonna fit all these things into like a box and try and say, hey, look, we're going to deploy some clusters. We're going to scale them up, but how are we going to do it? And then where are we going to deploy our applications at? And then some of the constraints that we normally have. And HyperShift helps solve a lot of these because it goes from taking like 45 minutes to deploy a cluster down to like 10 to 15. And so if we look, one thing here, if just looking at this top level slide, is we have like multi-cluster management. You're in the middle, you have your traditional OpenShift clusters, and then at the bottom is more like your interfaces. So your cluster APIs, your network interfaces, runtime interfaces, and your storage interfaces. And so when you look at this stack, you can see like at the very top, all of your applications still deploy. They still do their thing just like they would in any other environment. But this time, instead of the control plane being a separate set of nodes, it's actually the separate set of pods hosted on a management cluster. And so traditional OpenShift cluster, right? We have our control plane nodes that we can see over here in the bottom left. And then we have our worker pool, right? And so these are traditional compute nodes, worker nodes. Then you have your network load balancer and stuff like that. And so when we look at why HyperShift is really like the amount of spend that we have on our compute costs in AWS or GCP or Azure, we always deploy 3 control plane nodes and then n amount of worker nodes. And traditionally, what we found is that like the control plane can actually be scaled back, and we don't really need to have 3 full-on compute or control plane nodes. We can actually host those on a management cluster and then have the computes out there, just like you would normally do in any kind of EKS or AKS or anything like that. So some of the stories that come around or that come with the why behind HyperShift are like it takes forever to create a cluster. It takes a lot of compute to host a control plane because traditionally you're deploying like an M5 XL for your control plane nodes. And then I don't want admins or developers to have access to my control plane. So I want this to be an isolated environment where only my cluster admins are actually doing what they need to do on this, not everybody. And personally, from our team, like we've been struck by this a few times where everybody had cluster admin on the management cluster, and it bit us. And then we have one large server, but it's really it's too much to host just one cluster. It doesn't make any sense. It's more of a waste. So now we can break this up and chunk it up. Right, and so the hosted control planes, it's an OpenShift topology, same idea. It solves for cost and time to provision. It's portable across clouds, and it provides a strong separation of concerns between management and workloads. And what we do, the portable across clouds is awesome because it really is. You can use it in Azure, you can use it in AWS, and you can use it on OpenShift virtualization. And the time to provision, again, a traditional cluster deploys in like 42 minutes, anywhere between 30 in 42 minutes, and a HyperShift cluster takes about 10 to 15. And then this is just a slide showing some of the cost savings that you get. And this is because the savings come from not having the control plane nodes. Now that's three nodes per cluster that you don't have to account for anymore. And so it makes it very nice. All right, and then on our management cluster, we can see that it's one or more hosts, right? So you can have a single node, you can have a 3-node compact cluster, or you can have a traditional cluster that's hosting that's used as your management cluster. And then when you spin up a cluster, a hosted cluster, it will create a namespace. It'll create all of the control plane pods in that namespace, set up a load balancer, and then set up a node pool directly for those for that hosted cluster. And we'll go into this. I know we're looking at pictures right now, but we'll see the interaction on the shell here pretty soon. And if you think about like where hosted control planes comes from, it's part of ACM, the Red Hat Advanced Cluster Management for Kubernetes. And Advanced Cluster Manager is like a giant umbrella. And under that you have the multi-cluster engine, which really has the HyperShift operator, but it also has the Hive operator. So when you think of like these provisioning and deprovisioning services that we have, this is really what ACM is. This is what it's meant for. It's meant for that multi-cluster management, provisioning, deprovisioning, and stuff like that. And Hive and HyperShift, they serve very similar functions, but the way that they do it is just slightly different. And so the use cases are just a little bit different. And to kind of go into that a little bit, HyperShift, when you think about like an EKS or an AKS deployment, all you have is your compute nodes. And so HyperShift is built around speed and agility, and Hive is really built around like automated provisioning of the cluster, simplified provisioning of the cluster. So when you deploy a Hive cluster, it's traditional, 3 control plane, 3 compute, whatever, or 1 compute, 2 compute, whatever it is. And then HyperShift is going to be all basically just the compute nodes and then host the control plane on the management cluster. And then we can see in the middle of the screen here on the slide for the HTTP namespace and project, when we create a hosted cluster, a namespace gets created. Generally, it's like clusters dash your cluster name. And then inside of that namespace, you'll have like all of your control plane pods. So your API server, etcd, ops server, all that stuff, OLM. And then when you do like a OC get nodes or whatever, OC get node pool, you'll see like only the compute nodes. And then you can access it through the console and stuff like just like you would in any other cluster. And this is just more of that story about ACM being the big umbrella, and then you have Hive is one aspect of it. The assisted installer is actually another one that you can do for bare metal, and then you have HyperShift. All right, awesome. And then so this is just showing what's on the management cluster. So when we create a cluster, we actually create a hosted cluster resource on the management cluster. That creates a node pool resource, and then the operator actually completes the rest of it. And so it spins up the namespace, it creates all the pods in that namespace, and then it actually starts, as the resources are coming up and as the node pool is actually becoming ready, all those pods are coming up, and then the console API will become available. And if we were to look at it, we could actually see like the cluster operators on that hosted cluster are becoming ready and available. All right, so we're going to stop here, and we're going to go over. I'm going to share this tab instead so we can actually see what's going on. All right, so the reason why we put the HyperShift pattern together is because it really comes down to dogfooding, right? It's something that we want people to use. We want people to use it to help do like rapid cluster provisioning, and we use it, right? So instead of us having to go back and rebuild it manually every time we do something wrong or whatever, it made sense to make it a pattern. And so again, it comes down to the ultimate dogfooding. And the way it's set up, if you're not familiar with the patterns and the pattern framework, the bill of materials that you need that basically describes where everything is in the cluster is in Values Hub. We take a look. And I've got a bunch of stuff commented out because a lot of this stuff was already kind of created before we did the demo. But just so you know, we'll kind of go through everything. So we have a shared values file, and we'll go over this. But what this is this gives us an opportunity to template out another config where we can say, hey, look, we want these components that are like specific to this pattern and we want to be able to simplify the user experience. So that way, if you see values-HyperShift, you're like, oh, let me go take a look, and then you can kind of plug away and knock some stuff out. But in our Values Hub, we are creating our namespaces, our subscriptions, and we are also creating our Argo CD applications. One of the operators that we use is called this S3, this ACK. It's the AWS controller for Kubernetes, but for the S3 controller. And what this will do is if you have permissions to set it up and you can create S3 buckets, then this will create those S3 buckets for you automatically. There's another operator called Crossplane that does a very similar, probably more broad infrastructure management, but this ACK S3 controller, it's an AWS managed and controlled operator. It works quite nicely. I already have a bucket created, so I didn't want to create another one, so I commented this out. This group sync operator was something I'm messing with just to try and sync the GitHub groups from an OAuth provider. That way I can, instead of going in and saying, hey, I want to add, user 1 through 10, I can just say I want to map this group and then sync it down, sync all the users from it down. But it's not done yet. I haven't completely finished this. And then the multi-cluster engine, this is a piece of the advanced cluster manager that we enable. And then inside of that, we enable a feature called HyperShift. And again, we have our Argo projects, our Argo applications, but just so you know, there's nothing super crazy going on here. I've disabled the OAuth, so that way we can just kind of kick it around and kind of get an idea of what's going on. So if I get out of here and I look at the values-HyperShift. Now, inside of this, we have a create bucket. So if this was set to true, then we would expect that ACK S3 controller is enabled. And then we give the bucket a name, the region that we want it to. And even though S3 is a global service, we do still have to define a region that we want the bucket to be a part of. And then this tag here is just something that we've started adding. So that way, when we're going back, we're trying to clean up buckets from previous deployments. We don't inadvertently delete the wrong one. And then this RBAC here is to create a cluster role that only allows the very specific resources that we need, or access to the resources that we need, the APIs that we need to create hosted clusters. Now, you might be thinking like, well, why there's a separation here? So we're trying to maintain the self-service aspect here. And to do that, you have to give a user access to the hosted control plane API or the HyperShift API and allow them to be able to create, remove, and delete, or create, update, and delete hosted control planes, node pools, some secrets, and stuff like that. And so, if you don't set it up this way, then you have to basically give them cluster admin, and that can be disastrous, as we've seen a couple times. Now, if we wanted to set up OAuth, we in our primary cluster, our production cluster, we actually use GitHub as an OAuth provider. So we use GitHub every day for all of our work, and so it just made sense to let GitHub manage our users since all of us are there. And so what we do is we just say, we tell the OAuth provider, like, hey, here's all the things that are important to us. So we want to enable it normally. The type is going to be a GitHub. The secret that I want you to create is called this, OCP GitHub OAuth, and this is actually an external secret. And then the client ID for our GitHub OAuth provider is going to be this, and then our org is validated patterns. And then on top of that, if you also wanted to do Let's Encrypt, you could also go into values.aws. And then we would just uncomment out the Let's Encrypt, uncomment out the region, or if we want to use the production or staging URL for Let's Encrypt, and then we would uncomment out this part of the cluster group here. And then like everything else, it would just be like pattern sh and then make and install. Now we're going to go ahead and pretend like I already did this, and then do an OC get app. So I'm going to say, oh, and I'm just kidding because I need to export. HyperShift. All right, now OC get apps. All right, and so the cool part about what just happened, this is actually a happy accident, as my boy Bob Ross would say. This right here is just it's proof that our RBAC is in place and working, because before my GitHub account had access to do whatever it wanted to do. So it was cluster admin. So now I can't even list applications. And so it really restricts what I can do on the cluster, which is what I need it to do, because I need to be able to create clusters at will and not worry about deploying a pattern on top of it and maybe just like stomping something out, or deploying a resource that might stomp another resource out. And so it helps just kind of protect us from ourselves, and mainly me protecting myself from me, because I've done this like 4 times. But if we look at the applications, it lines up with what we deployed in the values hub. So we have our vault, and then we have our HyperShift hub, and then we have the HyperShift application itself, and then going external secrets. So now if I do an OC, let me go into the charts, I'm sorry. So charts, all, and then we'll look at HyperShift. We'll look at the templates, and then we'll look at the multi-cluster engine. So the operator itself, it deploys multi-cluster engine, and then we deploy this CRD, and we're telling it, hey, the target namespace that you're going to deploy everything in is multi-cluster engine, and then these are just the features that we want to enable. All right, and so this is it's a generic multi-cluster engine deployment. The big difference here is that we have the HyperShift feature true, and before 4.15, I think up to 4.15, might have been 4.16, AWS self-managed HyperShift was tech preview. But I think now, as of 4.16, it's been set to GA. But it's been GA for like on-prem, like OpenShift virtualization and stuff like that. So it's an awesome feature. It's been around for a while. And honestly, that's all the deployment is for HyperShift. We create a secret, an external secret for our AWS credentials, but that's really just to spin up the bucket and to interact with the initial cluster stuff. But outside of that, it's pretty simple. Oh, and I'm sorry, I'm jumping around here because now I'm like, oh yeah, we could look at this. So if we take a look at the cluster role, what I'm doing is I'm giving it access to the HyperShift API. I'm saying, hey, look, you can do whatever you want to do on node pools and hosted clusters. On the Hive API and cluster deployments, go wild. On Open Cluster Management, which is part of it, it's just part of the ACM API for managed clusters. Go ahead and you can look at them. And then some of these additional API groups here, there was one, I think it was this infrastructure API that I needed to add, and I don't remember exactly what the reason was now that I'm trying to say it out loud. And then here's part of your primitives, right? So we're saying, hey, look, you can get the events, you can look and create config maps, you can look and create PVCs, pods, look at logs, secrets, nodes, all that stuff. And what that does is it gives our team the ability to do what they need to do, maybe a little bit more than what they need to do, but they can't do everything like they could before. And so it just kind of worked out to be something that we really needed to have, and it just took a little bit of time to figure out. So, all right, so again, we have our apps, everything is deployed. So let's take a look at our clusters. So I already created a hosted cluster called demo. So if we take a look at it, so now we can see that I've got a hosted cluster named demo. It's on OpenShift 4.16.17. If I wanted to get the kube config, that's what the secret name is called. It's completed. And so now if we look at node pools, we can see that I've got a node pool in the US West 2A availability zone. So it's basically in the US West 2 region. I've got one node. It's, so one desired node, one current node. And then it's also on 4.16.17. Now, the cool part about this is that, say if I wanted to scale this up, so I can do an OC scale node pool. Replicas and 2. Now, if you've ever scaled up a pod, if you've ever scaled up any other resource like a machine set or anything like that, then you know that this is a common practice. It's awesome. So if we get OC, get NP and N clusters, we can see that we've got 2 desired nodes now, but only one is active. And so that's because it takes time for the node to spin up. So the hosted cluster is going out and saying, hey, look, I've got 2. The node pools are saying, all right, look, I need 2. So it's going through that process of standing up a new machine. It's going to check it into the cluster. And then eventually, in a few minutes, it'll become available. So if we do a OC get pods minus in clusters-demo, these are all of my control plane pods. So if you remember, sorry if my keyboard's too loud. Our cluster name is demo. And since this is our management cluster, right, we've only got 3 nodes. It's a 3-node compact cluster. We created a cluster called demo. All of the control plane pods are in the clusters-demo, in the namespace clusters-demo. Now, I don't have any compute availability for that cluster from where I'm at right now. So what I would need to do is I would need to create the kube config and then export it, or I could get the kubeadmin username and password and then log in via the API. So what I'm going to do though is I'm going to do an HTTP. I'm going to create. And so what we're saying is use the hosted control plane binary. We're going to create the kube config of the cluster name demo, and then I'm going to dump it out to temp and then demo.kube. And so now you can see that I'm in my cluster called demo. And then if I do an OC get nodes, I've only got my 1 worker node. Now, if you've ever used EKS or AKS or GKE or anything like that, then this should be very familiar to you. Like you only have the compute environment available to you. So if I were to do an OC, who am I? Oh, wait, it's right here. Actually, I'm gonna undo this. Export, and then we're gonna do that. All right, and then we're gonna jump over to this cluster. Bam. And this cluster is going to go away like really soon, so don't worry about sharing kubeadmin passwords or anything. And so if we look in our OpenShift cluster, you know, it's a typical deployment, OpenShift console, all that stuff. We can see that I've got my cluster deployed. And the reason why we have this drop down here is because once you install the MCE operator, it acts a lot like how ACM would act. And so it kind of gives you a different look into the console. So if we look at the installed operators, we can see I've got all the operators deployed, right? Multi-cluster engine is part of ACM, and so it gives me access to this local cluster or all clusters. And so if I go to all clusters, I can see I've got my demo available here. I can see that if I click on it, I can scroll down to this guy right here, and I can get the console, and then I can open this up. And then copy the password to it. Share this tab. Bam. Bam. Come on, little buddy. All right, here we go. All right, and we'll log in with kubeadmin. All right, and so now we can see like I've got another OpenShift console. I've got my compute. Now my second node is checked in. So now I've got 2 nodes. And then, but for all intents and purposes, right, I've got an OpenShift cluster that's available to me that I can start deploying operators on if I wanted to deploy operators. The OLM is there. It's not any different between a traditional OpenShift cluster or a HyperShift cluster. OLM is OLM, so whatever catalog you have access to, you can use and deploy operators from. So if we jump back over to the terminal, how did I create that cluster, right? So if I go, so the way I do it is you can download the binary And what I'll do is I'll update the YouTube with download links, and I'll put the gist with all the commands and stuff like that I'm running. I'll have the links to the pattern and then some automation that I wrote to make life easier, because while I was doing it via command line forever, Ansible's just a lot cooler to watch, and you can kind of like fire and forget. So, but to create a cluster, there we go. We'll call it demo 2, and then I'll put this in US West 1. All right. And so we can see here what we're saying is I'm just creating some environment variables. My goodness. I'm creating some environment variables, cluster demo, right? The cluster name, the region, what type of machine do I want to deploy, and the number of replicas. And then I'm saying use the HTTP binary to create a cluster of type AWS in the region, and the infra ID is going to match the cluster name. The name of the cluster is going to match the environment variable, and then our STS credentials. So this is a short-term, short-lived token session, something like that. This is a new feature from the HyperShift team where they wanted to limit the blast radius of credentials on the cluster, right? And there's a term that they used, or a way that they phrased it, that I cannot remember right now, but it was least privilege. They wanted to implement the most amount of least privilege that they could across all of the deployments. And then we're defining where my pool secret is, what instance type I want, how many node pools I want, so replicas, right? And then the role that we have to create for the STS stuff to work. So it's some permissions and stuff like that. And inside of my HyperShift automation, I have all of this kind of broken out so you can use it if you wanted to. And then your domain that you want to create, or that you want to create the cluster in. Now, let's say that I know for sure that I need to deploy across multiple availability zones. And so right now what this is going to do is it's going to create a cluster in US West 1A, right? If I need to have it across multiple AZs, then I would actually, there's another line option that you can hear, add, called zones. And then it would be like US West 1A, West 1B, West 1A, 1B, 1C, 1D, whatever, so on and so forth. All right, so what we're going to do, let me just go ahead and set all this back up. So again, we're going to create the cluster. So I'll run this. And then this is going to use Cluster API to go out, and it's going to spin up all the VPC information, right? So it's going to go out to the AWS. It's going to create a VPC. It's going to create the subnets, internet gateway, all the things that we're used to seeing in a cluster deployment. And then it's going to apply the hosted control plane sauce, right? So that's going to be creating the namespace, creating the secrets, making sure that it can access the bucket and S3 for the OIDC config. And that's what we see here, right? So we've got the IAM roles, and now we're looking at the applied Kubernetes resources, right? So creating the namespace, creating the secrets and stuff like that. And then we are starting the node pools. So if we take a look at the hosted cluster, we can see that demo 2 is starting to spin up. And we can see that the node pool is starting to spin up. And if we look at like AWS machines, we only have the AWS machines for the first demo cluster, and that's because it hasn't gotten that far yet, right? So the cluster itself is provisioning, the control plane is spinning up, the hosted control plane is coming up, and then as that's happening, once the node pool reaches a certain point, then it'll start provisioning the machines in AWS, and they'll check in, and then we'll start seeing these machines coming in. So again, the AWS machines is another resource within the HyperShift API. The machines is part of the OpenShift machine API. And so just to kind of show you like the different ways of getting the same information, but like to kind of give you a status of like where things might actually be, in the process. So if we do an OCHC, and we can see now, like, okay, we're starting to spin up some operators, but hey, my API is not available yet. And so this is what we're going to see. Like this, if we were to sit here and just watch this, like you'll see it kind of going through different phases. Once the cluster operator for the console comes up completely, then this will go back to being like a normal, console-OpenShift-console demo 2 or whatever. So let's take a look at the hosted cluster resource. Oh my goodness. So if we take a look at this, it's a standard YAML format, but inside of this we can get our cluster ID, we can get all of our DNS information, so like what zone we're creating stuff in, our etcd components, and so we are kind of tricking the cluster into believing that etcd is legit, like it's because it is 3 pods in one namespace versus three pods across different nodes. But we can see all the different things that we're used to configuring in our install config. So like a FIPS, this infra ID is, if we left this alone, it would generate that like that 5-character GUID and then associate it with the cluster ID. But when we define this, this actually allows, so maybe something doesn't delete correctly, or maybe it gets interrupted or something like that, and you have to go back. We found that it's so much easier to go back and destroy infrastructure when you know for sure what the infra ID is, and when you can set it to something like super simple, you don't have to go look for it. All right, and so then again, if you've ever done an OpenShift deployment, you're used to this, where you're defining your cluster network, your machine networks, service networks, all that stuff, defaulting to OVN Kubernetes, all of our traditional platform configuration things. So private VPCs, private subnet, or if we have private subnets, we can do private endpoints, and we can actually do disconnected deployments with HyperShift. We just haven't done it. And yeah, just going through all the different services that are available, and then like the status. All right, and so now let's take a look at pod minus in. And we can see pods are starting to come up. Pods are still rolling. And so if we do an HC clusters. Demo 2. So we can see, looking at our demo, the demo 2 cluster, that because the nodes aren't completely available yet, we don't have any resources yet. And so if we do like an OC get cluster operator, we can see this is a traditional deployment, right? Like with pods are still spinning up, operators are still spinning up, they're still going through their deployment phases and stuff like that. So this is a traditional rollout. This will probably take another 5 or 10 minutes, but then once it's up, it's a OpenShift cluster for all intents and purposes. And then again, you could go into OLM, you could deploy GitOps stuff on top of that, like if you wanted to start deploying patterns. There are some operators that aren't compatible yet, but like for the most part, I think that all the big ones that most people use are available now. Michael, I can't see anything yet. Are there any questions or anything?
Don't have any questions in the chat. I mentioned that 4.17 OpenShift 4.17 went GA this month. So we're up to 4.17 now. Next release 4.18 is targeting first quarter.
Yep.
Yeah. Any questions from the audience?
Oh, I have lots of questions. I'm just processing through them right now.
You're dazzling us all, Johnny.
So going across the count, we don't have any issues going cross count, do we, with this?
It all comes down to your STS credential, right?
Okay.
So because that's the credential that you're going to use. I guess that's probably another. Let me show you that.
Yeah, because I know, like when I was reading some of the 4.17 documents the other day and watched one of the OpenShift things, they were talking about the fact we can start using instance profiles now instead of having to have a long-term admin token for deploying the clusters, which that's huge for us.
So let me do this, and then I'll just do something special like this. So if I look at my token, what it's doing is it's going out and it's saying it's taking your user ID, because it does use the traditional AWS credential. I don't know why I went for that and looked at that. Sorry, I'm trying to talk and think at the same time. That's just not working. But yeah, so it uses like the traditional AWS credentials, or environment variables or whatever to establish that STS credential. But yeah, that once you say, hey, look, here's the user I want you to look up. So that user, as long as that user has access to the account that you're trying to deploy to, that's what I'm trying to say. Then it should be able to create the credential and then do its thing.
Okay. No, and that's really good because we try to do everything with roles, and if we do a cross account role, that should work just fine. So
yeah. So if I'll do a make build here, make sure I'm in the right place. All right, so what this is doing is just running an Ansible playbook that does the same thing, but instead of it's going out and saying, hey, I'm going to establish my STS credential, right? So it's going to go out and get the token, save it to a file, and then it's going to check to see if that cluster name exists, and then if not, start creating the cluster. And so then it'll dump everything down into a file when it's all done. And yeah, so on the STS thing, as long as that account that you're using, as long as it has access to the account that you're trying to deploy to, it should work. Now that logic might get a little tricky if you're using multiple accounts, right? You might have to do, set facts and stuff like that if you're using Ansible.
And that was the other thing I was wondering is from a networking standpoint, let's say we've got two accounts where we have private, not public facing endpoints on that. Do we have any concerns where we have to make sure that the networking and the rules are all coming in between everything?
So you're talking about having two private networks basically with host. So having a management cluster with hosted control plane and then having private networks kind of downstream, right?
Yep.
I don't know, to be honest.
Okay.
I can actually, let me reach out to Adele and I'll ask him because he would definitely know.
It's not like I don't bring you all sorts of funny questions anyway.
No, but they're good. They're good.
Because I mean, in a lot of our cases, we tend to deploy multi-account, everything behind VPCs. We'll typically have things networked together, but we'll a lot of times have Palo Alto stuck in between where we got to do break and inspect between account monitoring. And then I missed the first couple of minutes of this. So when you're deploying out of this, and just to make sure that I got this right, the control plane is in the hosted, the ACM, and it's just, is it using the same etcd or is it standing up another etcd in there?
It stands up its own etcd. So like for this demo 3, when we go, and once this finishes, I'll run over there and check it out. But oh man, maybe I'll just open another tab. Yeah, so what it'll do is like when it stands up the cluster, it will create a namespace called like clusters-cluster name. And then inside of that namespace, it creates 3 etcd pods and like your API server, your kubeauth, all that stuff, right?
Yeah.
And from there, what it does is it just basically tells, it kind of fakes out the node pools and says, hey, look, you've got 3 control plane, etcds, you're good to go.
They're just in spaces.
Yeah.
Okay, that makes sense. All right.
So I'll share this one. All right, so if we do OC-get pods minus n.
Yeah, when you were talking about the namespaces was about the time I was coming in, so that's why I was curious.
Gotcha. Yeah, so you see, like this is the namespace that gets stuff. This is the management cluster, by the way. So if I do OC-get nodes, I've got a 3-node compact cluster.
Yep.
I do I've got the MCE resource stood up here. And so, yeah, basically any cluster that we create, we tell it to, right? We say, prefix it with this clusters dash, and it's the default, but like you could set it to something else if you wanted to. But yeah, when you stand it up, one of the resources that gets stood up is the namespace, and then that namespace is like the clusters dash your cluster name, and then it starts spinning up all the pods in there. So it'll set up the secrets and RBAC and all that. If I do OC-get secret, and we can see that this is our pool secret, right? So if you look at that string that we ran, we said the pool secret is this. So it's actually giving you the pool secret. When it's done provisioning though, it will, if I can find it, it's here somewhere. kubeadmin. Oh, it's no, it's actually it's not there yet. So if I do get. So just in the primary clusters namespace that only your cluster admins would have access to, by the way. You can see like each cluster gets its own admin kube config. It gets a kube admin password, right? And so that way you can go in there, somebody can reset something, you know, and you can go in and hopefully fix it, or you can access it if it breaks, you know.
So one last question. I saw you had like a long deployment string on this one. Have you used Ansible to go and deploy this pattern?
Yes. Okay. To deploy the pattern, no. But to deploy the clusters, yes. But we use our traditional pattern deployment stuff. So
I kind of figured.
yeah. So if I so all right, the pattern lives here, and I'll send this directly to you, Porter. But oh my God, I'm getting the wrong one. Yeah, so this one. So here's where the repo lives. The HyperShift automation, that's in, I think it's in our normal validated patterns repo as well. But the HyperShift automation is just like once the pattern's deployed, it makes it's just like go in here, update some bars, make build, you know, or if you wanted to do like literally everything, I've got a pull request I'm working on right now where it's gonna be like a make all, so it'll go through and do like the IAM stuff first, and then set up the then do like the hosted cluster stuff.
Cool.
But the pattern, everything's in either Values Hub, like all your traditional subscriptions, applications and stuff like that. The HyperShift specific things, like do we want to create the bucket? I've already got a bucket existing, so that's why I set it to false. What region do I want my bucket to be created in? Even though S3 is global, we still have to tell it what region. And then this RBAC thing, this is for our GitHub OAuth. And I brought this up earlier, but the big thing about this is that if we don't set up OAuth and we don't set up RBAC, basically everybody's admin. And when you're deploying multiple patterns that might have resources that talk to each other, it can become problematic.
Yeah.
And then inside of Values Global, this is just where we're declaring the OAuth config since that is a global config. And then in AWS on our production cluster, we're setting up Let's Encrypt. And so that's where all that lives.
So here's a thought that runs in the back of my head is, let's say you've got this advanced cluster manager on this one, and maybe in the same cluster or in another cluster you've got DevHub running, and then DevHub has a screen or a tile or a section inside of it where it comes in and it says, I need a development cluster, and a developer can go in and push a button, fires off AAP, AAP goes and deploys this out, and then returns them back a set of credentials. They can go into, hey, you got 5 hours or 5 days or whatever it is, go beat this little cluster up, and then poof, it just goes away. Or hey, I hit a button and it just redeploys it and goes on. Yeah. I'm thinking about it that way from a developer standpoint, where instead of not only having like our multi-tenants that we've been talking with you guys about and stuff, but also having the ability for somebody to have maybe a bit more wide open controls on it, so they can just go in and do an experiment in an area, but it's a short-lived.
Yeah, I mean, and that's honestly, that's what this is perfect for. So if I just looking at this, right, like this is my inside your AAP, it would talk to this cluster.
Yeah.
Right. So your developer would go into AAP and say, I want a cluster called Demo 3, right? And it's going to live for, like you said, 5 days. And it needs this type of machine because of like GPUs or whatever, right? AI. And so then they would go in, they'd plug that stuff in. AAP would say, boom, put it together. It would make the call using the HTTP binary or the API to this. Yeah. This guy would spin everything up. And what I do, so just out of mine, I do home clusters, HTTP, demo. Oh, okay, it's not ready. Commons, I think there's that. So I dump everything out into this cluster info. And then what that does is it says, hey, here's your cluster name.
Yeah.
Here's your infra ID. Here's your region. Here's how you get to your console. And here's your kubeadmin password. Now, the other cool thing is that you can actually set up each one of these clusters with OAuth. So you can set up HTTP passwords, so that way you're not using kubeadmin. And you can still use RBAC and stuff like that. So you can set up HTTP password, you can set up OAuth back to Keycloak, right? And you could have all that stuff kind of like built into your provisioning.
Exactly.
And then by the time it's done, they would get this file and it says, hey, you log in using your Keycloak ID, whatever, here's your permissions. And as long as they have that kube config and or access to this role, cluster admin on that cluster, they can do whatever they want and it won't affect your hosting cluster.
Exactly. Yeah, that's exactly what I was thinking. That's got a lot of power to it.
Yeah, it's awesome. And like we use it quite a bit, and I'm really talking about, I use it every day. I mean I use it every single day because it is just like I'm able to spin up a cluster really quick. I can do something, and it makes that one-off thing that I just want to go see if this works really quick. It makes it so nice because I can just spin something up, takes 10 minutes, do my thing, and then I can kill it, and I don't have to worry about it. Where it might take 10 minutes to kill it, it might take 45 minutes to deploy it if I was going to do this on like a single node or a 3-node or whatever, a traditional deployment. So it makes that workflow so much better.
Well, think of the cost savings too, right? Because
100%, yeah.
We've got a test cluster up right now. Like Russell's doing a bunch of work in it, but there's no reason for that thing to run 24/7 and sit there and eat up costs. So yeah, we could stand it up, run a bunch of tests against it, tear it down.
Yeah, and it's awesome, and it's awesome. And so the other part of that too is you're only setting up compute, right? It's not like you deploy it now, right? And you're setting up 3 control planes and 3 compute. You're actually just you're deploying pods on the hosting cluster, and then you're deploying 3 compute nodes. And so that's where the cost really, I mean, like you really, really see it there. And I think for us, and I don't know if Anthony knows off the top of his head, but it was double-digit savings for us because we went from like just crazy amounts per month to, like it was like a 60% savings, if not more. It was awesome.
Oh, I can see that. I can easily see that. That's the first thing that popped into my head is because, we were in that cluster today and we're like, oh man, maybe we should tear this down and redeploy it. But on the weekends and everything else, like if Russell was like, oh, hey, I need to go work on this. Oh, I got to go work on an RFP. Let me just tear that down, go over here for a few days, come back, restand a new one up.
Yeah. And Hive, the cool part about Hive is when you deploy a cluster in Hive, it's actually got a setting in the spec that you can go in and basically say, hey, is this thing running or is it hibernating? And so if you're going on the weekends and it's something like, hey, I don't want to delete this, this is my baby, this is my favorite cluster of all time, I can't get rid of it. You put it to sleep on Friday and then wake it up on Monday, right? And that's something that you can do either through a cron, or you could do like, hey, I've got a workflow, right, where I come in and I say up or whatever, and I just change something I commit it through Git, and I'll let GitOps do it. You know what I mean?
So with the typical, like one of the issues we've always run into is the certificates on OpenShift, like being able to put them asleep for like, greater than a 24 or 48 hour period, because then we got to go and reset all the certs and everything else. This doesn't have that.
So it will, you'll see it, right? There'll be a little bit of a delay as it's coming up, but it'll start signing them. In Hive, it controls all of that. So like when you wake up a cluster after say 3 or 4 days, it goes through and it's controlling those CSRs, and it's going through and it's saying, hey, approve. With HyperShift, it just takes a little bit longer because the nodes come up, they start checking back into the control plane, and then it'll eventually do it.
That's brilliant. Okay. Russell, we got some work cut out for us. We got to change a couple of our clusters.
Thanks, Jonathan.
You're welcome. But we deployed demo 2 while we're sitting here talking like 15 minutes ago. And so this is completely done, ready to go. One thing I do want to show you, and it's because I can never remember. So inside of HyperShift, inside of this version of MCE, right? It's basically, it creates a config map and it says, hey, these are the available servers, or I'm sorry, these are the available clusters that I can provision on this version of OpenShift, right? Or this version of HyperShift. So right now, because 4.17 dropped like last Monday, I think it's still pretty brand new. So when MCE updates, this will eventually update, and then this will say like 4.17, 4.16, 4.15, 4.14, and then drop 4.13 most likely. So you've got a range of supported clusters that you can now deploy on HyperShift, right? So maybe you've got somebody that's set in stone. Like I've got to have 414, right? I've got it for whatever reason. I got to have it. You've got that ability to do that. And with Hive, you have the same capability as well, right? You can actually go in and say, hey, I want, this version and stuff like that.
I love it.
Let's see.
With 4 minutes left, is there something we want to cover near the end here, Johnny? I mean, this has been great, by the way.
No, that was it. I just wanted to make sure that that we saw, we can deploy clusters easily. It's easy to spin them up using Ansible. You can use a command line. GitOps workflow is what's next, but that's just a little bit more effort because now you have to get the CLI into the cluster, or you have to start making API calls and stuff like that. So it's really trying to get that logic down, and then bundling that up with Hive and just really kind of showing like the split. This is something that like I have Steve, you and I have been talking about this for a long time now, but like have both of those side by side so we can kind of see like what does it look like from a deployment standpoint and management standpoint, and like resource wise, what's it actually spinning up. But on the HyperShift side, it really comes down to its agility, right? Quicker, better, faster, and then giving our developers and our admins that ability to go out, spin something up very quickly, do what they need to do, and it can live forever, or we can tear it down and redeploy. But it really anchors itself towards that like pets versus cattle conversation, right? These are cattle, and so this is something that like we can do. We can tear it down. We can test a config. We can test a deployment, an application. How is it going to interact? And then we can tear it right back down, and we don't have to worry about, oh man, this is going to take forever. Did it clean everything up? Did it kill the VPC? All that stuff, right? It's very nice.
It changes the way I think about multi-clusters and even doing multi-tenancy for development teams. Right?
Yeah.
Like I want to get all of our health platforms into one area, one development model, and we're putting security and wrapping some things around it. But now I have the potential to broaden what they can and can't do, because I can actually put really better demarcation lines between things in this. There's some real interest in here that this is gonna. We're gonna use it. I can tell you that much.
Yeah, and I'll send you the links to the automation and to the pattern stuff, and I'll add you to my branch. Well, I mean, I'll point you to the branch that I'm using, so that way you can kind of see how we set up OAuth and all that stuff. And if you have any questions, because you're using GitHub as your OIDC provider, so or I'm sorry, KeyCloak. We're using GitHub, and so if that's something that you wanted help working through, we could definitely do it, because that's something that like I've definitely done it a ton on the HT password side and then on the GitHub side. So I mean, it's another config. So
yeah, and I did share the patterns link and your blog post in the chat, but it sounds like you have more specific things that you can share with Porter here.
And if not,
oh yeah, awesome. Yeah, that's a good one. And then so there's another blog out there that's talking about it talks about setting up HyperShift HT password. Yeah. And the reason why I did this is because I don't want to say it wasn't well documented, but it wasn't placed well in our documentation that was easy to find. And so now that they've actually gone back and revamped some of it. So it's nice to find, and it can go through it. But this blog is something I put together to kind of solve that problem, because we had people like reaching out to me like, hey, how do I set this up? I'm like, I don't know.
cool.
But yeah, that's it.
Very cool. Thanks so much, Johnny.